What if a flaw in our own biology wasn't a mistake at all? Today, we're diving into a fascinating medical detective story where an apparent error in the body might just be its most clever escape plan. It's a pretty wild idea, right? I mean, we're all taught to see a flaw in the body as a problem that needs fixing. But what if a glitch in the system is actually its greatest defense? So to get started, let's look at the problem this defense is trying to solve. Okay, so it all starts with a really critical challenge for some newborn infants, a high-pressure system inside their bodies that has gone seriously wrong. The condition is called posterior urethral valves, or PUV for short. It's a rare thing, thankfully, but it's a serious malformation that basically creates a blockage, and it stops urine from leaving the bladder properly. Probably the easiest way to wrap your head around this is to think of the urinary tract like a plumbing system. With PUV, you got this major clog right at the end of the line, but the system keeps trying to flush, right? And that just builds up a ton of pressure. And this is where the stakes get incredibly high. All that back pressure travels all the way up to the kidneys, which just aren't built to handle that kind of force. This can cause severe and permanent damage. We're talking about serious kidney disease. For these tiny infants, the risk is huge. Some studies showed that up to half of them could end up facing this outcome. But, and this is where things get really interesting, in the face of this dangerous pressure buildup, it seems nature might have its own escape plan, a kind of unexpected built-in safety valve. I mean, what if the system didn't just have to take the hit? What if it had a way to vent all that dangerous pressure, like an emergency release to protect the most important parts? Well, you know what? That's exactly what some doctors and researchers started to notice. In some of these really high-pressure cases, the body seemed to develop its own pressure-relieving systems. They even gave them a name, pop-off mechanisms. And this is the wild part. When you look at what these mechanisms actually are, they sound like more problems. I mean, you've got pouches forming in the bladder, urine leaking into the body, or even flowing backwards into a kidney. By any normal definition, these are anatomical flaws. The researchers themselves had this brilliant analogy for it. They said these things act like the exhaust valve of a boiler. When pressure exceeds a limit, the valve pops. It's just a perfect way to think about it. The whole idea is that these flaws might be there on purpose, to stop a catastrophic system failure. Okay, so that's a really cool theory. But you know how science works. A cool idea isn't enough. You need some solid evidence. So, a team of researchers decided to put this theory to the test. They decided to do a systematic review and meta-analysis. Now, this is a really powerful technique because you're not just looking at one study, you're combining the results from a whole bunch of them to get one single, much more reliable answer. And this process is no joke. It's incredibly rigorous. They started out with 588 different articles. Then they painstakingly filtered out all of the duplicates, all the studies that didn't meet their super strict criteria, until they were left with just 10 high-quality studies for their final analysis. And those 10 studies, when you put them all together, gave them this incredibly powerful data set, covering a grand total of 896 children. Now, with a number that big, they could finally make a direct, statistically powerful comparison. The big question, do the kids with these pop-off mechanisms actually have better outcomes than the kids without them? All right, so this is the moment of truth. What did they find when they finally crunched all those numbers? So it all boiled down to this one simple comparison. On one side, you have the group with the flaw, the safety valve. On the other, the group without it. Which group fared better in the long run? Well, the answer was, wow. It was incredibly clear. After all that analysis, the protective effect came down to one single powerful number. 52%. So what does that actually mean? It means that the kids with these pop-off mechanisms had a 52% lower risk of developing chronic kidney disease. That's not a small difference. That is a massive, life-altering discovery. The conclusion was pretty much unavoidable. These so-called flaws weren't just flaws at all. They were acting like a biological shield, protecting the kidneys from all of that relentless high pressure. So, case closed, right? The safety valve theory is proven. Well, you know, in science, it's almost never that simple. And this is actually a sign of really good science. The researchers themselves are the first ones to say, hey, hold on, let's be careful here. The results are absolutely significant, but there are some important things to keep in mind. For one thing, the 10 studies they used were all pretty different from one another. Plus, there wasn't a standard agreed upon definition for some of the key terms across all the studies. And that's exactly why the researchers are emphasizing that we really need new studies designed from day one to track this effect with consistent rules for everyone. So, where does this leave us? In the short term, this research could really help doctors better predict which of these young patients are at the highest risk. But the bigger picture here is just, it's incredible. It shows the sometimes paradoxical wisdom of the human body, and it forces us to ask this really fundamental question: how many other biological flaws aren't mistakes to be fixed, but are actually elegant solutions that we just haven't understood yet?